In this video, we are going to solve part B of the physics question paper from NEET 2023. So our first problem is, a bullet from a gun is fired on a rectangular wooden block with velocity small u. When bullet travels 24 cm through the block along its length horizontally, velocity of the bullet becomes u over 3. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. The total length of the block is, and these are the four options. So according to the question, the bullet travels a distance 24 cm through the block, and in doing so its velocity changes from u to u over 3. So first we need to find the deceleration of the bullet. Now for the motion in one dimension, we know that v square is equals to u square minus 2as. Here v is the final velocity, u is the initial velocity, s is the distance travel, and a is the deceleration. That's why we consider the negative sign. Now this can be rearranged as a is equals to u square minus v square over 2s, which is equals to u square minus u square over 9 by 48, and this is equals to 8u square over 9 times 48. So this is the deceleration of the bullet, and then it further travels till the end of the block and stops, so that the final velocity becomes v is equals to 0. Therefore we can write u square equals to 2as when the final velocity is 0, or this can be written as s is equals to u square over 2a. So if you put the value of a, then you will get 27 cm. That is, the total length of the block is 27 cm. Therefore option D is the correct answer. Our next problem is, the radius of innermost orbit of hydrogen atom is 5.3 times 10 to the power minus 11 meter. What is the radius of third allowed orbit of hydrogen atom? And these are the given options. So it is given that the radius of the innermost orbit of hydrogen atom is 5.3 times 10 to the power minus 11 meter. Now we know that the radius of the nth orbit is given by the formula Rn equals to n square times r naught. So if we put n equals to 3, then we will get the radius of third allowed orbit of hydrogen atom, which is 4.77 Armstrong. So option C is the correct answer. Our next problem is, calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is 0.15, and these are the four given options. So according to the questions, it is given that the coefficient of friction mu s is equals to 0.15. Now for the stable equilibrium, the force of friction must be equals to ma, or we can say that ma is equals to mu mg, or a is equals to mu g. Now if you put the values for mu and g, then you will get the acceleration is equals to 1.5 meter per second square. Therefore the correct answer is option B. 10 resistors, each of resistance capital R, are connected in series to a battery of EMF capital E and negligible internal resistance. Then those are connected in parallel to the same battery. The current is increased n times. The value of small n is, these are the four options. So when the resistors are connected in series, the equivalent resistance is 10R. Therefore the current in series combination is given by Is equals to E over 10R. Now when the resistors are connected in parallel, the equivalent resistance is given by R over 10. Therefore the current in parallel combination is given by 10E over R. Now according to the question, it is given that Ip is equals to n times Is, that is, current in parallel combination is n times the current in series combination. So we can say that 10E over R is equals to n times E over 10R, and from this we can evaluate the value of n, which is 100. Therefore option A is the correct answer. So let's go to our next problem. Our next problem is, a horizontal bridge is built across a river A student standing on the bridge throws a small ball vertically upward with a velocity 4 meters per second. The ball strikes the water surface after 4 seconds. The height of the bridge above the surface is, and these are the 4 given options. So let the height of the bridge above water surface is h, and the total time taken in this process is 4 seconds. Now for the motion in one dimension, we know that s is equals to ut plus half at square. Now here s is minus h as the ball is going down the bridge, and u is 4, t is 4, and a is the acceleration due to gravity, which is 10, and if we put all these values, then the value of h will be 64 meter. Therefore correct answer is option B. Our next problem is the net impedance of circuit as shown in the figure will be, and these are the 4 given options, and this is the given circuit. Now we know that the impedance of LCR circuit is given by Z is equals to square root of R square plus omega L minus omega C whole square. Now according to the question, R is 10 ohm, L is 50 over pi millihenry, and C, the capacitance is 10 cube by pi microfarad. Now from the figure, as you can see, the frequency is given 50 Hz. Therefore angular frequency will be 2 pi f, which is equals to 100 pi radian per second. Therefore if you put all these values in the formula of impedance, then you will get Z is equals to 5 root 2. Therefore option B is the correct answer. Our next problem is a satellite is orbiting just above the surface of the earth with period t. If small d is the density of the earth and capital G is the universal constant of gravitation, the quantity 3 pi over capital G small d represents, and these are the 4 given options. This is a problem of simple dimensional analysis. That is, we need to find the dimension of 3 pi over Gd. But here 3 pi is a dimensionless constant, so one can drop this term. Therefore, we only need to calculate the dimensional formula for 1 over Gd. Now, the dimensional formula for G is m inverse L cube t to the power minus 2, and d is the length, so it's simply L. So if you put the dimensional formula for G and d, then you will get the dimensional formula of 1 over Gd, which is m L to the power minus 4 t square. Therefore you can say that the quantity 3 pi over Gd is proportional to t square. Therefore option A is the correct answer. Two thin lenses are of same focal length f, but one is convex and the other is concave. When they are placed in contact with each other, the equivalent focal length of the combination will be, and we have to choose the correct answer from these given 4 options. We know that the effective focal length of a combination of two lenses having focal lengths f1 and f2 is given by 1 over f equivalent is equals to 1 over f1 plus 1 over f2. Now using the sign convention of lenses, we can say that the focal length for the concave lens is minus f and for the convex lens is f. Therefore if we put these values in the formula, then we will get the equivalent focal length or 1 over equivalent focal length is equals to 0, or we can say that the equivalent focal length will be infinity. Therefore option C is the correct answer. Our next problem is for the following logic circuit, the truth table is, and these are the 4 given options. So let's focus on this logic circuit. Here are two inputs A and B, and both are passing through a NOT gate. So after passing through a NOT gate, A will be A bar and B will be B bar, and after that they both passes through a NAND gate. So the output will be A bar times B bar whole bar, which is equals to A bar bar plus B bar bar, and we know that A double bar is equals to A and B double bar equals to B. Therefore the output is A plus B, which represents an OR gate. Therefore the correct answer will be option 1. Our next problem is a very long conducting wire is bent in a semicircular shape from A to B as shown in the figure. The magnetic field at the point P for steady current configuration is given by. We know that for a conducting wire, the magnetic field at a distance r is given by B is equals to mu naught I by 2 pi r. And for a semicircular wire, the magnetic field at its center is given by B is equals to mu naught I by 4 r. Therefore, net magnetic field at point P will be B is equals to magnetic field for the semicircular wire minus the magnetic field for the conducting wire. Now, if we put the expressions for these two quantities, then we will get the magnetic field at point P is mu naught I by 4r times 1 minus 2 over pi. Now, if you apply right hand thumb rule, then the direction will be away from the page. Therefore, the correct answer is option B. Our next problem is the resistance of platinum wire at 0 degree Celsius is 2 ohm and 6.8 ohm at 80 degree Celsius. The temperature coefficient of resistance of the wire is, now we know that the relationship between temperature and resistance is R is equals to R naught times 1 plus alpha delta T, where delta T is the change in temperature and alpha is the temperature coefficients of resistance. Therefore, from this expression, alpha can be written as 1 over delta T times R over R naught minus 1. Now, according to given data, delta T is 80 and R is 6.8 and R naught is 2. Therefore, if we put all these values, then alpha will be 0.03, or it can be written as 3 times 10 to the power minus 2 degree Celsius inverse. Therefore, the correct answer is B, 3 times 10 to the power minus 2 degree Celsius inverse. Our next problem is, an electric dipole is placed as shown in the figure. The electric potential in 10 to the power 2 volt at point P due to the dipole is, and these are the 4 given options, and it is also given that epsilon naught is the free space permittivity and 1 over 4 pi epsilon is denoted by K. We know that the potential due to a dipole is given by V is equals to K times Q times 1 over x minus d minus 1 over x plus d. Here d is the distance of the charges minus q and plus q from the point O, and x is the distance from point O to point P. Therefore, if we put all these values, that is x is equals to 5 times 10 to the power minus 2 and d is equals to 3 times 10 to the power minus 2, then we will get V is equals to kq times 1 over 2 minus 1 over 8, which is equals to 3 over 8 kq times 10 to the power 2. Therefore, the correct answer is option D. Our next problem is, in the figure shown here, what is the equivalent focal length of the combination of lenses assuming that all layers are thin? And these are the 4 given options. Now, according to lens maker formula, 1 over f is equals to mu minus 1 times 1 over r1 minus 1 over r2. Here r1 and r2 are the radius for the lens surfaces. Now, let for the first plano-concave lens, the focal length is f1. Therefore, r1 is equals to infinity, that is the radius for the flat surface, and r2 is plus 20. Therefore, if we put these values of r1 and r2, then you will get that 1 over f1 is equals to minus 6 by 200 centimeter inverse. Now, let's consider the second biconvex lens and let its focal length be f2. Therefore, r1 is plus 20 and r2 is minus 20, and if you put these values, then 1 over f2 will be 5 by 100 centimeter inverse. Now, for the last plano-concave lens, let the focal length be f3, and here r1 is minus 20 and r2 is infinity. Therefore, 1 over f3 will be minus 6 by 200 centimeter inverse. Now, from the formula for the equivalent focal length, we can write 1 over f is equals to 1 over f1 plus 1 over f2 plus 1 over f3. Now, if we put all the values of 1 over f1, 1 over f2 and 1 over f3, then we will get 1 over f is equals to minus 1 over 100, or f is equals to minus 100 centimeter. Therefore, correct answer is option B. Our next problem is, A wire carrying a current I along the positive x-axis has length capital L. It is kept in a magnetic field B, which is B is equals to 2I cap plus 3J cap minus 4K cap Tesla. The magnitude of the magnetic force acting on the wire is, and these are the four given options. We know that the magnetic force on a current carrying wire through a magnetic field is given by F is equals to IL cross B. So we basically have to perform the cross product of L and B. This can be written as I times this determinant. Here the length is defined along the x-axis, that's why all the other components, that is the y component and the z component of the vector L is 0. That is, L can be written as only Li cap and B is 2I cap 3J cap minus 4K cap. Now if you calculate this determinant, then you will get IL times 4J cap plus 3I cap. Now magnitude of the force will be mod of F is equals to IL square root of 4 square plus 3 square, which is equals to 5 IL. Therefore option B is the correct answer. The xt graph of the particle performing simple harmonic motion is shown in the figure. The acceleration of the particle at t equal to 2 seconds is. In the graph, the time period is given by t is equals to 8 seconds. Therefore, omega can be calculated using the formula omega is equals to 2 pi over t, which is equals to pi over 4 radian per second. Therefore, position of the particle can be represented by xt equals to a sin omega t or sin pi t by 4. Therefore, the velocity is given by Vt is equals to dx over dt, which is equals to pi by 4 cos pi t over 4. Therefore, the acceleration of the particle will be a equals to dv dt, which is equals to minus pi square over 16 sin pi t over 4. Now, at t equal to 2 seconds, a is, or the acceleration is, minus pi square over 16 meter per second square. Therefore, option C is the correct answer. So that's it for now. See you in the next video, and do not forget to subscribe my channel for regular updates.